Hey guys, I want to go ahead and talk about some of these graphing polynomials. And went ahead and did it just to save some time. So this is the original function, okay, and I took some pretty difficult ones. But if you notice here, I just went through the steps. First thing we want to start off with the Y-intercept. So that's the easiest thing to start with. Whenever you don't know what to do, plug in some points. And then the easiest one is the Y-intercept. So how do you find it? Set x equal to 0. Well, if you notice, if I plug in 0, 0 here, and 0 here, I'm going to be left with negative 1. Therefore, my first point is right here. Okay? So that's one big key thing that I know about this polynomial. Second thing is the end behavior. The end behavior has to do with these two little things right here, these arrows here. Now, because it's a cubic, I know that it's going to look like something like this. Now, since it's a positive, just looks the way it is. So I know it's going to go up on the right and it's going to go down on the left. Okay? So if you notice here, what I did, I just kind of put two little arrows and to show what it would look like. Alright, so that's my second clue. As we keep going, the next thing is the number of bumps or turns. So this guy, because it's a cubic, the number of hills or bumps is going to be one less than the highest degree. So because this is a degree of 3, it's going to have two little bumps or two hills. Okay, so something like kind of like an S shape. Okay. Alright, so we got our Y-intercept. We know our end behavior. We know it's going to have two bumps or hills. Next, we need to go ahead and find the X-intercept. Okay, and this is where the factoring comes in. So you're going to go ahead and set the y equal to 0. And when you do that, you can have this equation set equal to 0. And basically what you need to do is you need to factor. The problem is, though, of course, is a cubic, and we don't know how to factor that. So we need to use synthetic division. How do you do that? Well, you guys know synthetic division. And all I have to do now is, well, figure out what do I have to divide by. I'm going to have to use my rational roots theorem. And remember, it's p divided by q. So this guy is your p. Factors of negative 1, well, plus or minus 1. Factors of this guy here, x cubed, is plus or minus 1. So 1 divided by 1 is just, well, of course, it's just 1. So the possible zeros of this function that I'll divide are plus or minus 1. Okay, so then I go ahead and use my synthetic division. So I start off with the x cubed, and you notice there's a 1, there's a negative 3, and I almost messed up, but this is the x. Because notice it doesn't have an x here, so I need to account for the 0. And then the negative 1. And then I do synthetic division. Bring down the 1. 1 times 1 is 1. Negative 3 plus 1, negative 2. 1 times negative 2, negative 2. 0 and negative 2 is going to combine, negative 2. 1 times negative 2, negative 2. Negative 1, negative 2 gives you negative 3. It doesn't eliminate, it doesn't become a 0. Therefore, x equals 1 is not a factor. So I can't use it. Alright, we use the next one. Negative 1. Same thing. Same process, synthetic division, bring down the 1. Multiply, you get negative 1. Negative 1, negative 3 gives you negative 4. Multiply gives you positive 4. 0 and 4 gives you 4. Multiply gives you negative 4. That gives you negative 5. Again, doesn't work. So x equals negative 1 is not a factor. So what does that mean? Why can't we factor it? Well, the reason is because the intercepts are decimals. And they're not real whole integers, and that's what makes it a little bit difficult. And that's okay. So what can we do? Well, we can go ahead and pick some points. Alright? And if you notice here, we know our end behavior. We know this guy's at 0, it passes at negative 1. So I decided to go ahead and pick negative 1 as a reference point, see what that gives me. And then I also decided to do positive 1. Just pick some easy numbers. So I plug in negative 1 to my function. And I did the math and I got negative 3. Well, I did the same thing for the positive one, I did the math, and I also got -3, which was interesting. Okay, now this is what I got right here. But see, I don't know if it's gonna go up here and then come down and then go up. I really don't know. So there's something called Rene Descartes' rule of signs, named after Rene Descartes. And it basically tells us that there's a way to figure out how many positive real roots and how many negative real roots you're going to have. So the positive ones are going to be on the right side because the positives are on the right, and the negatives are going to be on the left. So what I do is you take the original function, okay, the positive, you just take the original function, and you just want to count how many times it changes. So this guy's a positive x cubed, it changes to a negative. Okay, so that's one change, but then it stays negative. So positive to negative, that's one change, and then it just stays negative. So there's one positive real root. So I know that here, somewhere here, the line's going to cross. There's going to be one positive root. Okay, so the next thing I do is I plug in -x, okay, and I go ahead and evaluate. I do my math. -x to the third power, that becomes a -x cubed. -x to the second power, remember it's even power, so that becomes a positive. Okay, and then that's x squared, but times that -3, that becomes -3x squared. So this has a negative, negative, negative. There's no sign change. That means this guy here is going to cross, never reaches the x-axis, never crosses the x-axis. So now I have a better idea of what this guy's going to look like. So this guy, it passes through here, I think goes down here, goes down, and then goes up. Okay, and you can see here that makes sense because it has two bumps. My end behavior is down, up, and one positive real root right there. No negative real root, that means it doesn't cross this side. And that's a sketch. Okay, so let's go ahead and do one